Hello Internet. I'd like to do a follow-up on these soldering tweezers, and I've been messing around with them for a little bit because I found something that I thought I would never find. So I'm gonna go ahead and plug the power brick and plug the cable into it, and the voltage leak was a thing apparently. So let's see what voltage leak we have. Let me go ahead and zoom in into the oscilloscope a little closer. As a matter of fact, let me go ahead and reset the oscilloscope, and I'm going to try the old tweezers. And so what I'm getting is a small spike, probably. So one division is 1 volt, so we're probably getting like 1.2 volt or something like that. If we were to switch to a multimeter, let's go and switch to the multimeter right here, and I'm going to take I believe I take the positive wire to the unit ground, to the soldering station ground. And please forgive me, I'm gonna have to move things around. Things don't really reach. Okay, so, and if we measure for DC, so we're getting about 3 volt DC. So 3 volt DC is not too bad, all things considered. AC is not measurable. So then we take the other soldering station, let's say the ones that use the 245s, and we're getting about the same 3 volt, so that's good. Let's use a T3A soldering station, and we get hardly anything. So T3, actually it's a T3B, yes, T3B. Do we have any AC leak? Just 1.1, just a little, just maybe like 1 volt. Let's see if I can swap the probes around. See if that makes any difference. Nope. Almost 0 voltage leak on the T3B station. Now, let's put this ground wire, the negative probe, into the ground of the AC jack, into the wall outlet, and so it's kind of jumping all over the place with the DC mode. If we switch to the AC, because we're getting AC, and we get like 52 volts. And if we look at the oscilloscope, let me go and switch over to the oscilloscope. There. And without even powering anything on. So it doesn't look like we're getting anything, it seems. But this is not really accurate because my ground isn't properly grounded. So let me see if the ground isn't connected. So I need to connect the ground on the probe. So now the probe is grounded through my tester, through the power supply, and then into the ground. Or is it? No, probably not. Let's go ahead and fix that. I want that ground grounded to the ground. So put that into here and here. There we go. So I can't even see much on the screen, and that's because we need to dial things down, like down to the minimum, to the lowest limit that we can get. And let's see. You see this? Do you see this? Holy cow. Do you guys see this? Okay, what if I don't connect this the way I did and just connect it here? Is it the same thing? Yeah, it's just it's the same thing. So this thing is shooting 50 some volts AC into your circuit. It doesn't matter how you use this, because you can use this through I can use this through the DC, my lab power supply. Let me go ahead and try to get the ground here. and it'll do exactly the same thing. Well, maybe a little less. So right now, see right now. Okay, hold on. So you can't see it, can you? I have to change the view. Hold on a sec. Hold on. Side main. There we go. So with that, once it's powered through a regulated lab power supply, which is HM310T, we're getting about 12 volt AC. Do you want 12 volt AC shoot into your circuit board? No. No, you do not. Okay, now I'm gonna plug that same that end of the cable, the other end of the USB-C cable, into the USB charger. Not the one that they provided, but a separate one. See if it makes any difference. It does. We're shooting about what? 10, 20, 30, 60, some, I don't know. 10 volt? Yeah. 50, 60. So basically, this thing, if I'm not mistaken, and please do comment in the comment section below if you think that this will kill your circuit, kill your electronics, if you're using this. I don't know. Most likely not, because of the low current. Kind of like when I'm injecting 5 volts or 6 volts or whatever into the core to measure the core resistance. But the current is so low that it does no harm. But we're talking 52 volts AC leaking into this. And if I were to power it with a regular power supply, let me show you what the power supply look like, so you can. Yeah, this power supply here, Hanmatak HM310T is what I use, and and I don't know. I don't want to use this right now. From after what I've seen so far, I do not want to use this because I don't know if it's gonna hurt anything, and having a couple of $1,000 graphics card. This is a RTX A5000, by the way. I do not want to use this on that. Maybe on a 10 series or something like a 1070. I might have probably could do some experiments, but or on a dead card like I did in the video, actually testing this. But that was a dead card. I don't know. I don't know if that card's gonna work or not, because it's dead, got no core or anything. But if I were to use this on here, I would be very skeptical about the card working once again. So I don't know. Please do me a favor and do everybody a favor. Post your comments, especially the engineering people out there. Maybe I didn't test this the right way. I don't know. I'm not exactly an expert in testing these things. So I did the best I could with very limited knowledge that I possess. So I don't know. I'd like to hear your thought on this. So please comment below, and let's see what the conclusion is about this. Should we buy this? Should I use this? Should I not? Because this is a big if, very big if. Now the manufacturer replied to me about the grounding issue, and they said that these two screws could be used as a ground, but I don't see how that's happening. So I don't know. In any case, thank you for watching. Can't wait to read your comments. So please don't be shy. Goodbye.